right, good afternoon, everyone. Welcome back, or welcome to my first session, maybe, in case you weren't in my last one. This is kind of a new type of session. It's an unplugged session, so you can basically bring your questions about, anything but the weather, I guess. I don't know that much about that, but I've prepared a couple of topics here that we can talk about. But basically, the idea is just like for the C# internals talk later today, that you tell me what to talk about. And, of course, it has to be a little bit in my area of expertise, so I've put a couple of things here. We can talk a little bit about some of the cool new things in C#, or maybe, you have some questions like, gosh, I wonder why they did that thing this way in C#, or, something that's kind of mysterious and maybe I can help to demystify it. I can do similar things for Visual Basic, though I'm not a Visual Basic expert, but I know quite a few things about that. We can also talk about CLR internals, which includes hardcore debugging, which was a session topic that was proposed for TechDays this year, but didn't make it in favor of this one, so we can talk a little bit about that as well. And of course, reactive extensions link, which has been the topic of my work for the last, well, let's say 3 years or 4 years or something. So, anyone who wants to pick something? I can't really hear anything. Okay, so maybe I should start and pick something, and if something comes up, just let me know, and then we'll actually go into some subjects here. So let's see. Reactive extensions. Okay, good. So how many of you know what reactive extensions is? Okay, a few. How many of you have actually used it or are using it? Okay, a little bit. Okay, so let me do like a quick intro into reactive extensions and give you some idea of what it's really all about. So as the unplugged sessions sort of unfold, there are no slides, so there's nothing in my sleeves. So that's kind of nice. So the idea of reactive extensions is to give you the ability to actually write queries over asynchronous event streams of data. Now, what does that mean? Now, if you look around you, there's a lot of data that's actually coming to your application in a reactive manner, meaning it's data that's actually pushed to your application and you have to react to it. So classic event handlers, of course, are good examples of reactive streams. But other things include like GPS sensors, Twitter feeds, things like, updates on the internet over an RSS feed. You can all model those kind of things as event streams, okay? Things like stock information, for example, as well, traffic info, you just name it. And so what we've done with RX is really we've said, like, how can we model, push-based event streams using a simple interface as simple as IEnumerable of T, and then allow you to write, like, queries on top of that. So you actually want to be able to express your querying problems by using LINQ. So let's actually just do a little quick intro into RX, and I will just give you the core concepts. The basic idea of RX is just like with LINQ. Once you know the core concepts, you can basically start exploring on your own pretty easily. So let's see, that font size is, I think, reasonable, but let's boost it a little bit. So the way to actually get RX is by going to NuGet. That's the preferred way of actually getting it. And there are a number of packages. I won't go into too much detail about the different packages, but like if you're doing a UI application, typically you want to use RX-XAML. That includes everything you need for XAML-based applications. So in this case, I'll just do RX main and just do things at the console. Now I need your cooperation. Who knows some .NET event that you say, gosh, that's the best .NET event ever invented, and I can do a demo using that one? Somebody has like, favorite event in preferably in the system namespace or something, or like, in the BCL, of course. No favorite events? Okay, well, I can always use File System Watcher, for example, if that's acceptable. So let's just do the File System Watcher as an example. In fact, like, last time I did a session like this at an internal conference, TechReady conference, there was somebody actually saying the File System Watcher and took a little bit of figuring out that API. So it should be good to go now. So let's actually take a look at the file system watcher, right? File system watcher over here. And we've learned a couple of things about file system watcher, namely that you have to give the path where to listen for things. I assume everyone knows about the @ sign in C#. Maybe that's kind of a very redundant kind of question, but I'll just talk to it. Just allows you to escape things, and in particular when you do like me and you have ctemp, and kind of embarrassing bug that you have for a demo not working is forgetting to escape this, and this is actually a valid string, because \t, of course, is the tab sign, and there is no such directory on the system. So I'll just use ctemp. Another thing of the file system watcher is actually not to forget to set to enable raising events, which is an artifact of system component model. This thing is actually set to false if you drag it to a designer surface, so that the file system watcher is not enabled when you actually design your components. But so the thing with the file system watcher is really that it's kind of this ugly API that's really a source of a lot of data. It can tell you when a file has changed, when a file has been created, deleted, all of that kind of stuff. But the thing is, like, traditionally you end up writing a lot of logic in here that makes life a little bit hard or cumbersome. So let's actually do file changes, for example, and just see whether we can get something to work here. Let me first check whether I do have a temp folder. Indeed, I do have a temp folder. That's typically where I keep all the important stuff. So let's do console write line here, and let's do full path. So just tell me that something has changed. I don't want my application to quit, of course, otherwise the whole exercise is moot. And so let's see whether I have to enable some other flags here. I believe I do. fsw dot. Let's see, what do I have to set here? Filter. Notify filter. I think I have to set the notify filter. I'm not completely sure. I do have to set this one. Okay, well, let's see. Let's first see whether it does something, okay? In fact, let me also do file system watcher.create. And so the whole goal of this little exercise is to show how ugly it can get if you do things with regular .NET events, and how beautiful it actually can get if you use reactive extensions instead. So let's actually just to do this kind of thing here. Okay, so created and changed. So let's see what's going on here. So this thing should be watching the ctemp folder, I assume. This thing is not a command prompt as admin, so we should be good to go. And so let's actually just do bar.txt over here and then save it. And so as you can see, I just did like how many interactions here. I did Notepad that actually created using create file. In Windows, it created a file. But then I hit save in Notepad, and in fact, like, apparently they're calling save file, or, some close handle thing or whatever multiple times in there. So every time I hit Ctrl+S, you see duplicate events coming out. And so people have always found this like file system watcher to give too much spurious notifications and stuff. And of course, the way to solve that is by having some local state somewhere, and then say like, oh, if the file has changed in the last minute or so, like, I don't want to raise the event again, so I will filter it, and the wheels start coming off pretty quickly, right? And so what we can do in reactive is really we can say, I want to really think about this in terms of a query. I want to wrap those events as observable sequences, and then I get a whole set of query operations that I can apply to them, including things like, buffer the events in certain windows of time, as for example, a good use case. So let's just show how you do that. So the basic idea is, once you are in the world of observable sequences, you get a whole bunch of query operators. And so those actually live on the observable class, just like in classic Link, you have the enumerable class, right? And so if you look there, you see like a whole bunch of things you can do on event streams. For example, let me just point out an interesting difference between Rx, observable programming versus enumerable programming. So here you have an example of, average, okay? So if you do an average between a whole bunch of values in an event stream, well, if you look at link to objects, right, average would actually block, and it would actually return a value when it has computed the average. Of course, in an event based world, you don't want to block till the last event comes, because those events may be going on for hours and hours. Like maybe you want to say, I want to get the the average value of the stock over a whole day. And so you see in the return type of things like average, sum, min, max, and all of those guys, that the return type is actually an IObservable of double or IObservable of something. So we basically come from a stream of events and we condense it into a stream that asynchronously will give you a notification when the aggregate value is available. And one interesting thing as well is actually, as you can see, it's awaitable. So I'll actually show you the await keyword applied to Rx as well in just a moment. So what I want to do is, in order to get this whole menu of things available on the file system watcher, I have to wrap it somehow. And in fact, there are projects on Codeplex that have wrapped a lot of streams or a lot of .NET events using Rx. But so let me just do a from event pattern here. And what I'm going to do is I'm going to say, dear file system watcher, I know that you produce file system event args like this, okay? And I just want to tell you that I'm interested in, say, the changed event or something. So I'm just using a reflective overload here. We have some other overloads as well. We have, in fact, 6 overloads. Some of them have to do with static events. The other ones are instance events. But basically what you have to give Rx is you have to tell us, or you have to educate us how we can start listening for events when we want to execute a query on top of the event stream. You also have to give us a mechanism to unhook the events, so that, for example, if you do a query where you say, I want to get the first 24 hours worth of file system watcher events, so you would actually say file system watcher.change.take until 24 hours or something. We have an operator called take until. Then after 24 hours, of course, we have to dispose the subscription to the events. So we have to know how to unhook things. So what I can do here now is I can actually just put that here, changed. And now what's going away is this plus equal syntax. Like you no longer hook up events using delegate chaining. Instead, what you do is you do change.subscribe, and now you can actually give us the callback. Now, you may say this just looks ridiculous, right? You're taking away one thing and you're giving me something else in return. That's of the same complexity. I'm just going to remove some of that stuff here. But so here I'm just going to do console write line of x dot. And so, as you can see, this is really the same as those callbacks that I had to begin with, right? I can dot into the sender, the event args, just fish the data of the event out. So why are we going through all of those hoops of making life, as I would say, easier? Well, I will show you how life gets easier right now. Okay, so here we go. Of course, subscribe is not the only thing you want to do. That's where the power of Rx comes in. So with Rx, you can actually say, I want to write a query on top of this thing where I say, from, event in changed, where the event.eventargs, full path, ends with, I don't know, .txt. That's not the way of doing file system extension checks. You have to use the system.io namespace. But you can get the idea that you can start writing those queries on top of event streams. And so what's really going on in Rx is we will subscribe to an event, and then, when events are happening, we will flow them through the filter, and if it passes the filter, we'll actually give them downstream and so forth. So you can start building those pipelines of query operators. And this is just showing a little piece of syntax here. So let me just take a look at that. Of course, I'll use res over here. So this is actually for changed. Let me actually use created. That will be a little bit easier here. Created. So I can just create new files with different extensions. Now one more thing is that a lot of .NET events, those don't have to be the only source of Rx, right? You can have a lot of things that are IObservable of T. .NET events are just one example. They're just very convenient for demo purposes. But what I wanted to say is when you come from events, typically there's a lot of stuff in the event tags that you don't care about. And what do you do in case you have some, piece of data that contains a lot of fluff that you don't care about? Well, the answer is you basically project it away, right? You say the data is in a shape that I don't like. The IT admin or the DBA that created this SQL schema was just smoking crack at some point. I don't like, the title field to be called title in some weird language or something. I want to project it to some other shape. So that's something you can do in Rx as well. You can say like, I don't like all of that indirection of event Rx and blah, blah, blah. You can say like, well, I just want to abstract this. I want to say like, from E in observable from event pattern, select E dot. And I can say like, I don't care about the sender. I only care about the event Rx. And in fact, I only care about the full paths. So at that point, created is an I observable of string that just gives you notifications whenever a file has changed. So you can project away all the cruft that you don't care about. And then, later on here, now things get more interesting. That's from path and created, of course, where path ends with. You can start refactoring things in the to-link way. Now, of course, this is not the only thing we want to do here. So let's just get the thing going first. And now here it's actually saying, well, X is now type string, so it can't have an event Rx. So I'll just call this thing path as well. So let me just write this one and see whether it actually does something. For some reason, my system tray icon always changes to forefront for console apps. I don't know why that is. Need to debug that maybe later today. But so here I have my application running now, and so let's go here and actually do echo, test into foo.txt. You see foo.txt is coming out. It's passing the filter and all of that kind of stuff. But if I do foo.bin, well, you don't see things coming through the filter, right? So the filter is really in effect. It's now seeing all the events being pumped into to Rx, but then it's not passing the filter in this particular case. Now, of course, we can go much more fancy. This is just one example. The example with the spurious notifications from Notepad, for example, is a good case for using certain operators. So let me actually do the changed thing, or let's just do created and show you some fancy operators you could use. So one fancy operator you could use is you could say, I have an event stream and I want to know how much events are really happening every 5 seconds or something. Like you want to do some aggregations on top of the events. Like if you want to do that manually, it turns out, well, you have an event handler sitting somewhere, you have a field sitting somewhere, you have to increment the counter in the field. Maybe you have to deal with threading, so you have to use interlocked increment and stuff. And then, things start getting more complex all the time. And so what you can do in Rx, you can actually write those queries that use time-based operations. So you could say var result equals created dot. And now you could say I want to buffer those events in windows of a certain length. So I could say I want to buffer those chunks of data into length of, say, for example, time span from seconds, and say, 5. So at this point, what's really happening is I have an I observable of string, and now I'm saying for every 5 seconds, give me a list that contains the values that happened in the last 5 seconds. So time is elapsing, events are coming in, but we will only send them to you every 5 seconds, given the list that contains the values. And so this will now be an I observable of list of t, or list of string in this case. And I can still do a console write line here, but of course I could continue here. I could say like, from buffer in, created.buffer, select buffer.length, for example, or count, I mean. So this would actually count the number of events that are happening every 5 seconds. There's a more efficient way of doing this. If you're not interested in the elements in the buffer, of course, you could do something more advanced here. But now I get statistics over here. Like the results now provide statistics, which are an I observable of int. So every 5 seconds, this thing will actually tell me how many TXT files were created on the system. So as I execute this thing, well, of course, after 5 seconds, it should come out and tell me there were 0 creations of things. So that's really what's going on right now. So it's actually telling me there were 0. But now I can start creating like, some values here. Like I can do quux, quud, quut, quuff. And then you see like, in 5 seconds, well, those 3 actually fired in that 5-second window and so forth. So now you see like, those analytics over the event stream just by chaining things together. Now, the beauty is that you don't have to care about the resource management yourself either. And that's kind of pretty interesting. Because at the end of the day, like, there's a lot of state here. There's a lot of like subscription logic going on. If the user says subscribe on the last line over there, we are really saying like, hey, buffer, or hey, select operator, do you know how to subscribe to the buffer? And the buffer will say, hey, do you know how to subscribe to the file system watcher, and so forth. So you have this whole chain of dependencies. But the beauty is like, what you get back out of subscribe is this subscription token that you can basically just hold on to. It's an iDisposable. And at some point you can say like, I no longer need those events. You can simply say subscription.dispose. And at that point, you will actually unhook everything. In this particular case, we'll stop timers that are running those buffers. We'll deallocate all the buffers that were used, and so on. So you get this rich composition of event streams. You can actually also have multiple event streams that you want to merge or something. But you also get this, nice way of doing resource handling and resource management. Just to give you one concrete example where people typically make a lot of mistakes is like, if you do sampling, right? You have an event stream and you want to say like, this event stream is going way too fast. I just want to get, values in that stream every 5 seconds or something. So you want to do some sampling. Now, to do sampling, you need to have some timer sitting somewhere, and you can do that over here. You can just do .sample, for example. We have a sample operator, of course. So say that you have a fast-moving stream and you just want to read values every 5 seconds. The resource management of that, if you have to do that manually, is pretty tricky. Like, all of a sudden you have an event handler sitting somewhere, right, that's firing stuff. But then you also have a timer that's firing every 5 seconds. And then in order to stop that whole computation, you have to have those two pieces that you have to cancel out correctly. Like if you forget the timer, values are still being pumped, are still coming into the event handler and stuff is happening with them. If you forget about the event handler but don't forget about the timer is reading sampled state that's not being updated anymore. So then you get stale values. So there's a lot of like things, moving parts that if you're not using RX for that kind of stuff, you have a lot of manual state management. An iDisposable for a timer, a subscription to an event that you have to unhook using minus equals as opposed to plus equals. And so there's a lot of, moving parts at that point. So just to wrap up this discussion or short intro into RX, if you actually have 12 onto observable, you see there's a whole bunch of stuff here, like aggregations. We have this beautiful thing called join patterns. So you can actually join multiple streams based on certain occurrences. So you can say, this is basically like Outlook rules. You can say, I have an event stream for mail from my mom. I have an event stream for mail about Windows Phone or something, and now I can do .end between those two things, which means if there is a mail, from mom and there is a mail about, Windows Phone stuff, at that point I can combine those two things and do a certain action. That's really what Outlook is doing as well, right? Like you're defining those patterns that if, certain flags are set to true, then things are being filtered through. So that's what AND is about. And there's a whole bunch of stuff here. You can do buffering, you can do error handling as well. You can also do combined latest, and let me just, talk to you what combined latest is, because that gives you a beautiful insight on how to think about those things. This thing, Excel, is actually nothing but combined latest in RX. Like, this is just combined latest on steroids. Why is that? Because like every cell is really an observable. Every cell is something that's continuously changing. Whenever the user enters a new value, something is changing. So if I'm saying over here, this thing equals A1 plus B1, I'm really saying, please combine the latest value of cell A1 and B1, and then whenever any of those two cells is changing, please combine them by doing a plus. The user is writing a plus over cells, but that doesn't quite type check, because cells are time axes of values, right? A cell is something that's changing. How can you do a plus between those two things? Well, the answer is that Excel is really doing an event handler for both cells, and whenever any of the two event handlers changes, it's re-evaluating this formula. So that's really what combined latest is in RX. And so in fact, one of the early samples I did at some point was RXL, doing Excel using RX. So that's that idea. So a whole bunch of operators here. We can drill into much more detail there, but this is sort of like a quick introduction. So are there any particular questions about RX, things that you sort of wonder, can I do this? Can I do it some way? Yep. Can you be a little bit louder? Okay, so how can you listen to database changes in a table was the question. The answer would be, whatever API you have. Like for example, in SQL they have this SQL. They have a SQL notification mechanism for database updates, right? I think it's in the system.data.sql client namespace. There's some SQL database watcher kind of capability. I believe it comes into the system. It started in SQL Server 2005, and so whenever there's an update to a table, you can actually register that in the database in the DBA command, and then it will actually send a notification. I believe it's using http.sys. It's using the HTTP stack to your application that something has changed. At that point, this is something you can totally wrap in an observable sequence. Just wondering, whether off the top of my head I can remember how that thing is called. So, Rx doesn't come with wrappers for everything in the world, obviously, but you can easily create those wrappers, and as soon as things are observable, at that point you can start writing those beautiful queries on top of them. I believe it's called System Data SQL Client. Something with notification. Yeah, here it is. SQL notification source. Oh, that's an enum. That wouldn't be very useful. But there's something here that allows you to do notifications for SQL database. Other databases likely have a similar thing, based on triggers for insert and so forth. And that's actually the main story of Rx, right? Out of the box, it's empty. It doesn't know about any streams. It's just this abstract framework that allows you to write queries on top of streams. And so traditionally you import .NET events into the world of Rx. You can do very similar things for things like database tracking. Does that somehow make some sense? Okay, any other Rx questions? Yep.
Is it used a lot in ASP.NET as well, or is it mostly used in console applications or Windows services?
Okay, so the question was what's the typical place where it's been used? In particular, has it been used in say ASP.NET? There's nothing really preventing you from using it in ASP.NET other than the life cycle of session management, right? You have your session and you have a long-running query on top of something. Then it starts breaking down, right? Somebody's waiting for the HTTP response to come back. How much reactive processing can you really do there? The answer is you can do a little bit of that, but with things like SignalR, SignalR actually comes in the box with observable wrappers. So if you have an ASP.NET service that actually says, well, I want to stream results back to my client in a push-based event-driven fashion, you can actually use Rx for that. Other cases are typically UI applications, but also background services for a lot of system monitoring scenarios, for example. We're putting a big bet on using Rx for those. Yep. Okay, so the question is how to create an implementation of iObservable on top of your own data stream, essentially. Yeah. Okay, so in fact, okay, let's actually dive a little bit into that. The basic operator is observable.create. So there's a number of gradations on how to do this. The bad reaction would be to implement iObservable of T yourself. Somehow people see an interface and they think, oh, I should implement this thing. That's doable, but there's a lot of edge cases, tricky edge cases to take care of. So you really have two options to implement observable sequences on top of your own stuff. So one thing is to create a class that derives from observable base. So you can actually say I want to have a bar of T. It's coincidental that looks like my name, but so you can actually say observable base of T here. And then you can just implement this subscribe core method that actually does some setup for you, including null checks and some threading stuff. But what you can do in subscribe core is you can start listening to a stream, and then you have to return out a disposable that actually stops listening to the stream, to the underlying implementation. Now, this is one way of doing it. Typically, you don't need a class for this kind of stuff. Typically, what you do is you actually use observable.create. So let me actually show you how to do the file system watcher thing without using from event pattern. In fact, I'll show you how from event pattern is implemented, kind of. There's some, exceptions to the main flow here. But say you have the file system watcher and you didn't notice for some reason it exposes .NET events, or you didn't see the from event pattern exist in Rx. You can just, basically create this created stream by doing this. You can say created equals observable.create of string, okay? And now what I want to say here is we have a lot of overloads, as it turns out. But the one I will likely go for, we have some beautiful ones for async, actually. So you can write async subscription logic, but let's not go into that one right now. But so what you pass in to create is really a Lambda expression that looks the same as subscribe, okay? So what subscribe look like? When somebody walks up to an observable, they say, I want to subscribe to you, and please call me back on this observer, okay? That's the way to feed data back into Rx and let query operators operate on top of it. So you basically get in an observer, and then you have to start firing things onto it. So I could say observer on next, foo or something. Like, this means like as soon as the user subscribes, we'll start pumping out values. In this case, we'll start pumping out value foo. Now this is kind of not what we want, right? But just to set up the skeleton, what you have to do at some point as well in here is you have to return a disposable that says, when the user is tired of getting events from this event stream, this is the way to shut up. Like, Rx will actually call this thing if it says, like, I don't need to see any further values. Like in Rx, you could say something like stream.take5, which means after 5 events, Rx will say, I don't want to listen to you anymore because the user only asked 5 values, so I want to clean up after myself. So that's what Rx really calls into, is a disposable to stop the subscription. So how do you implement a disposable? In Rx, we always say if there is an interface, and you have to implement it sometimes, we always have a static factory method that allows you to implement the interface simply by passing in a lambda. So you can say disposable.create, and this is the body of code that will execute when the disposable is triggered. When somebody calls dispose, this body of code executes. And so now what I'm going to do, as opposed to doing this kind of scaffolding, I'm just going to set up in the top level lambda, I'm going to set up the logic that has to run when Rx asks, please subscribe to this stream. In this particular case, what would I do? I would basically say, well, I want to create a handler, right? In this case, I want to create, well, I don't know what the type of the handler is. The handler is a file system event handler, okay? So, of course, this could be something totally different, right? This could be, setting up some session on some service or something, or making a web service call or something. In this case, I'm just going to set up some event handler, and I'm going to say when there is an object and an event Rx, I want to notify my observer. Okay, so observer on next of e.fullpath. Okay, so this is really just my handler. That's the thing that actually will start talking to the observer. And now I still have to hook it up. So what I would do here is fsw dot changed or created plus equals handler. And then, at that point, so when Rx comes in and says, like, I want to start listening to the file system watcher, we new up the file handler in this case. We give it to the created event. And then, we return a disposable that at some later point in time, Rx will call to stop listening to it. Well, what do you do to stop listening to a file system watcher? You would actually use the minus equal over there, all right? And so this is basically what from event pattern does, okay? Now, this basically has exactly the same semantics as those two lines, without using a select operator here. From event pattern is slightly more generic in that, it works on any .NET event. It doesn't make choices like e.fullpath on the user's behalf. But the thing is, like, something else you could do here is, for example, a good example is was in JavaScript. Actually, we also have Rx for JavaScript. In the HTML5 APIs, you have a geolocation API. And there you have to do something like, I don't know the exact syntax anymore, but you say create watch. So you actually tell the GPS sensor, I want to create a watch to notice whenever the user is moving, okay? And I want to feed out those events as an iObservable. So what you do there is you do something like create watch to set up a watch, and you pass in a function which is a callback that says, like, whenever the location has changed, I want to do something like observer.onNext. In JavaScript, it's with a lowercase o. It's exactly the same principle. But what createWatch returns is a watch ID. Okay, watch ID. That's the ID that you have to feed into a corresponding API in the HTML5 stack that's called deleteWatch. Okay, so you basically have to call deleteWatch with the watch ID at some point if you want to stop receiving GPS notifications from the GPS tracker. So in that case, the shared state between the creation and the disposal is just the ID. So you wouldn't have the plus equals and the minus equals kind of symmetry there. But you can basically wrap any kind of source that's push-based this way. Another example is system threading timer. Just doing a timer using Rx is very simple as well. Turns out the timer is already idisposable, so typically the only thing you do is just return the freaking timer out of the subscribe method, and that takes care of stopping the timer, right? So that's the ID. By the way, how many of you have actually used system threading timer? It's actually it's a pretty interesting thing. You know, we were playing a lot with that. Just to sidetrack a little, you're working a lot with those timers in Rx, and if you don't keep them alive, weird things happen. I don't know whether any of you has actually seen the case where a timer stops firing all of a sudden because you didn't keep it alive. Okay, let me, just want to tell a little story here. Let's do. This is actually, how should I say? This is more like, BCL trivia that actually are very good to talk about at the bar. Typically doesn't work to pick up dates or something, but talk about timers always kind of works. But so what you can do is you can do system.threading.timer over here, just create a new timer, right? And then you have to pass in the timer callback, okay? So we all know what the timer callback is about. We can actually do something like underbar goes to, and then we do some stuff in the timer here. So let me just do console write line, hello over here, right? So I have my timer, okay? But the interesting thing about this timer is you can also specify the state, of course, and you can specify the do time. Let me actually say like 10 seconds, or let me say 5 seconds over here. And then the period, let's just say timeout, timeout dot infinite, okay? So that's a one-shot timer that just fires once 5 seconds from now, right? Now, the thing is, if you don't route this timer for the garbage collector, and, somebody garbage collects the timer will never fire. And then you get, some very mysterious behavior. So, in fact, I could try to repro this. I'm not sure why I'm actually even doing this. But, let's try to do that. Static void create timer over here. Okay, so there's my timer. It's just creating the timer, but it's losing the reference to it. And then here I'll just do create timer. And then, I'll do some gc.collect over here. Let me just do the whole thing, wait for pending finalizers, and then collect again. And then I'll do console readline here to keep my application alive. And let's do console readline here to basically wait for the user to press enter. So the first time I press enter, I will actually start collecting stuff, so emulating user work. So if I don't press the enter key, in the first 5 seconds, the timer obviously will fire, hopefully. Otherwise, things are really kind of mysterious, so there we go. But if I execute it again, hope this works now and it hasn't been fixed. But so I pressed enter earlier now. This actually did a gc.collect of something that nobody's holding on to anymore, so the timer will not fire. So you have to keep, your timer rooted somewhere in case you don't want to lose it. This, by the way, is not a problem with the WPF dispatcher timer, the Windows Forms timer. It's purely system threading timer that has this behavior. And in fact, if you're interested, I invite you to take a look at the task.delay implementation in the BCL, which does something very similar to make sure that a timer that's sitting behind task.delay doesn't get collected early. But so we once got bitten by that, so that's the reason I basically pointed out. Good. Any more RXE questions? In fact, I could talk a little bit about this, but that gets into the hardcore debugging kind of thing. Somebody's interested in that, please tell me. Any other questions? Oh, there's a question. Oh, you were waving at me. Thank you. Okay, good. So let me actually. How many of you have actually used SOS? Okay, a few. Okay, so this particular case, the best way to actually find out about this is actually by using SOS, which is a debugger extension, pretty hardcore debugger extension. One thing that a lot of people don't know is you can actually use it from inside Visual Studio. So let me actually show you some secret recipes that, again, are very good to actually pull up at some point at the bar top and sort of show, like, let me just debug your application for you kind of thing. So the key thing is to go to the debug tab and actually enable native debugging over here. And so once you do that, you can do some fancy stuff. So once you have this, you can actually go here and let me set a breakpoint. Just press F5, okay? So there we go. So we just broken the debugger at this point, nothing fancy is happening. But now I can load this debugger extension called SOS. SOS, by the way, stands for Son of Strike. Strike was the original debugger that the CLR team was using when the CLR was still codenamed Lightning. So Lightning was the codename of the CLR, and in fact you can still see Lightning in the system icon of ILDASM, which is a lightning bolt. So that's a little bit of a trivia over there. But so what you can do now is you can go to the immediate window over here. And what you can do is you can actually load the Son of Strike debugger extension, and then you get a lot of magic commands in the immediate window. So what you do is you load C, Windows, Microsoft.NET, Framework, v40, 30319, sos.dll. Once you load this thing in here, now you have SOS available. And now you can write some magic commands in the immediate window. You can, in fact, do the same thing from inside WinDebug, which is the native debugger, that you can just download as debugger tools for Windows. That's that kind of thing. You can also do it in CDB, which is the command line version of this one. But let's just go here. Let me just show you an example of something you can do here. So you can do bang help. And bang help actually tells you about some magic commands in SOS that can actually be pretty useful to do a number of things. For example, one thing you can do is you can examine, all the threads that's currently being executed, and for example. But what I want to do here is I want to actually dump the heap. So I basically want to just find my timers, just to show you some of the commands you can do here. So you can actually say, or let me just let me not do actually in this case. What I want to do is, let me see. I'm thinking of a good example of some interesting use case here. We could do traverse heap, for example, and that would be one thing. Or we could do dump heap. Let's do dump heap, okay? So if I do dump heap, you basically get, all the objects that are currently running in the system or running in the CLR. Now, one thing that you should never fall into, and I've actually seen it happen to some developers, junior developers at some point, is like, you're analyzing some crash report of a CLR, managed code application, and you just do dump heap and you find, well, clearly something went wrong because there's a Stack Overflow exception and there's an out-of-memory exception and even an execution engine exception in my heap. Something really terrible went wrong. The answer is no, nothing went wrong. The thing is that there needs to be an out-of-memory exception on the heap in order to throw it at the point we're out of memory, because we can't allocate an out-of-memory exception when there is no memory, right? So like those things have to be pre-allocated. So this doesn't mean something bad has happened. However, I can basically go in here and just, to give you an idea here, we have the system threading timer that I just allocated. And so what I can do is I can actually, find the timer here. I could say dump heap -type for the timer. So here I find, my timers. And this is everything that starts with system threading timer. In fact, internally, the timer system has a lot of indirections. It has a timer queue and so forth. But what you can do now is you can actually identify your timer by looking at this MT thing. That's the method table. That's a unique ID for the type. And just to give you an example of something you can do is here you can actually see that there is something of that type sitting here at this address. So you can copy that address and do, which is dump object, and you will basically see this is my timer. So that's the timer I just created in my application. Now what you can do is you can do gc root. And gc root is actually this thing that finds whether this object is kept alive. Like if there is no gc roots, it means that the object will be reclaimed the next time the garbage collector goes. So here you can already see that this timer is just a dead man walking. At some point, if the garbage collector comes in, things will go away. But so this is actually the debugger extension that I was talking about. You can just load it in Visual Studio, and it's kind of cool, as opposed to having to deal with WinDebug and doing all sorts of crazy things there. Okay, any other questions? I could actually dive into some of that stuff. If you say, we got a nasty bug or something, like, do you have some tips and tricks? Good question. Could you use Son of Strike in unit testing to find out whether everything is cleaned up or not? I guess you could, using some p-invoke stuff. I haven't tried that one yet, so would be a good fun project actually. You can actually get some statistics, of course, but those may not be super useful. You can use the GC class and just find the number of objects and generations. That often gives you a good indication of the behavior of your application, but of course you don't get the coarse-grained or the fine-grained details that Son of Strike gives you. So, but yeah, I guess you could interop with it if you run your test harness under the debugger, so you can load it and inspect data structures. But yeah. In fact, there is an extension of this one as well called PSS Core 2, which you can download online. I don't know whether I can find it here. This one. Actually, there's also PSS Core 4 now for CLR4, but this is actually an extension to SOS, an extension to an extension, essentially. That gives you a lot of debugger extensions capabilities. So this may also be very useful to look into. Other questions about this subject? Okay. There, yes. Mm-hmm. Okay, yeah. So the case of the mystery memory being accounted for but not visible. So if you don't find it in the heap, using dump heap and those kind of things, the next tool I would use is VMMap. VMMap, I don't know whether you've used that one before. Okay, so VMMap is actually a sysinternals tool. Not sure whether I have it installed here. I think I do because I always configure my machines using those. But so VMMap would actually give you a clue of the memory being used by your application to get an idea of what's going on there. Well, VMMap is now starting. So VMMap is one of the sysinternals tools that Mark Rusinovich does, or did. I think he's still maintaining those. They typically work by actually inserting a hook in the kernel mode of the operating system to actually inspect data structures. But so in this case, for some mysterious reason, I'm looking at a process called build notification, which isn't very interesting. But let's just run this one. Okay, so this one is called console application 2, which is very useful as a name. And so let's just go here and look at console application 2. So it's actually trying to do something with it. Here we go. So this is console application 2, and as you can see over here, this actually breaks down the whole memory. So it knows about managed heap. Well, my managed heap is kind of super tiny here. This is this little portion of data. But you can actually see the different blocks here that are being used. And in fact, like for images which are the executables that are being mapped, or other things that are being mapped into memory, you also have mapped files. You can actually see exactly, at which offset, which image is being mapped into the virtual memory. So you can actually use this to start tracking down things. For example, I worked on WPF before. In WPF, we had a lot of interop with native data structures for bitmaps. So bitmaps wouldn't show up under the GC because they're actually done in native memory underneath. So this thing would actually show definitively whether the leak is in native memory or somewhere else. So that allows you to sort of narrow the search space. Other than that, you would use some memory profiler like CLR Profiler or some third-party tools to actually monitor the application as it's going, so that you can get an idea of when things start growing. There's no silver bullet, of course. To run this thing of snake oil in it, it sort of tells you what's going wrong. But typically there is some native memory that you're dealing with. Another thing could be that you have too many threads, because every thread by default takes 1 megabyte of stack size. So if you have a whole bunch of threads, but that's something you would easily see using banked threads, and then you would see how many user mode threads there are. Does that help to search? Okay. By the way, there's also RAM map. RAM map shows you the physical memory of the system. This is the virtual memory on a per process basis. It's kind of interesting to see, the physical memory as well, but not in this particular case. It's just fun to look at and to sort of come to a conclusion like, hey, I read this email or this piece of, data like a week ago. Why is it still on a standby list? Windows is still keeping it in there. Like, you went to in private mode to do some shopping or whatever you do in private mode, and then you look at the physical memory map and you see like, oh, there's still a lot of things being mapped in memory there. So it's kind of interesting to understand how the memory manager works, and those are great tools to get that kind of insight. I'm just being the salesman here for Mark's tools. This is RAM map. Looks a little more fancy because it has more bars with colors. It has a bar, horizontal and vertical. But here you can actually see exactly what's going on in memory. Kernel stacks and stuff. Actually, an interesting story about this. In Windows 8, we have a new thing in the network stack that I had to work with recently in Bing. I'm now working in the online services division. It's called RIO for registered I/O. And so registered I/O is a way of actually avoiding doing a lot of copies if you receive a network packet, so that you don't have to do a copy from user mode to from kernel mode to user mode. So you can actually do a lot of savings there. And so registered I/O works by reserving a chunk of memory and basically just mapping it into the user mode space. That's called non-paged pool. Now, what was actually happening is, in Windows 8 we have this beautiful new hybrid shutdown. So what's happening if you do a hybrid shutdown over here, I'm not going to do it now, but like if you do shutdown here, it's doing something called kernel hibernation, so it's actually storing a lot of the data structure, so it starts faster. However, if you have a memory leak in non-paged pool, it's actually saving the memory leak as well, because that's part of the kernel data structures. So in fact, I was rebooting that server, and I was messing around with it, trying to tune those, this RIO, registered IO networking API, and a reboot didn't solve the problem, because it was just hibernating for faster resume, those blocks as well. Typically, if you don't mess with any of that stuff, it doesn't matter. But in case you ever have to, the shutdown/s command actually really cleans up after everything. And then you also have now the new /hybrid flag. And if you do, this is actually what the shell uses. It uses hybrid sleep or hybrid shutdown. But if you do shutdown/s, it's still like an old-fashioned shutdown that deallocates everything. So just a little tidbit there. Any other questions? Okay, so let's actually go back to the slides. I have some other subjects that may be interesting. Let me do some suggestions. So we talked quite a bit about RX actually. So how many of you have actually used the new C# 5.0 async await features already? Okay. Any particular, questions about that one? Like, some interesting cases or things you've seen that you say, like, why is it doing this? Or like, yeah. Okay, so let me actually talk a little bit about the async feature and some of the interesting implementation tidbits there. So just to give you a little bit of context there. So what we have is this, I'm just garbage collecting my code here. So the little demo I want to do here is telling you how to write a library, essentially, when you're using await. The thing is, like, async await is super cool to actually do, like, for example, UI applications and stuff, but it does a lot of things under the covers for you. And in particular, what it does is it actually captures where things are happening, so we can post back to, for example, the message loop. So let me just add some references here. Oops, system Windows. Come on. This new dialog I haven't gotten used to yet. So I'm just going to use Windows Forms here to do some fancy stuff. But so say you just have a Windows form, right, and you want to do some asynchronous I/O or something. Just to show you, like, one of the things that async actually takes care of. Let's do new form here. Here we go. So we have a new form. I can do form load. Well, do I want to do load? I'm not sure. I'm just going to do some scaffolding here, application.run of the form, okay? So I'm just creating a little form here without using the designer. What I'm going to do in the form load is actually I'm going to kick off some asynchronous operation that ultimately comes back with some data. And, as opposed to, posting it to the UI immediately, it will use the async feature at some point, and then you'll see a noticeable difference. So I'll just mimic some background activity by using task.delay. So I'll just say like task.delay of like, say 2 seconds or something, right? And so when this thing actually fires, I'll do a continue with over here, just, to do the old-fashioned style. So I have some operation that's ongoing, and then I'm saying, like, when the operation is done, I want you to execute this block of code. So that's just doing the continue with approach of the TPL. There are other ways of doing this as well, like a lot of APIs use begin invoke, end invoke. Some other APIs use start and a completed event handler. But essentially, like at this point, I want to update the UI. I want to update the UI to say something like form.title or form.text equals datetime datetime.now.toString. toString. So just change the title bar, right? Like, the timer is sort of, a source of asynchronous computation that ultimately gives me the time. But as I execute this thing, you will actually see the threaded exception that's not atypical to be observed when you're doing this kind of UI operations. Don't know why it's taking that long. Okay, that's wonderful. I know what's going on here. Okay, so a little tidbit. For some reason I don't understand, but in Visual Studio 2012, when the compiler doesn't obtain the lock to the file to update the executable, by default it has a retry count of 10 now. In the past it simply failed. So when you see your build actually being slow for some reason, it's typically like it's just trying to do some retry logic because the file is still in use. I don't know exactly why they did that, likely because there are certain cases where you quit the debugger and the file is still being used somewhere, and then there needs to be some retry. The reason this thing is locked, obviously, is because this thing is still running. So. By the way, this kind of problem, again, selling Mark's tools in this case. For this kind of problem, a very useful tool is actually a handle. Okay, so you can just use, again, from sysinternals, you can use tools sysinternals over here, handle. It's not named after a famous musician or something. It's named after Win32 handles. So what you do in handle is actually you basically specify the name of the thing being locked, and it will actually tell you the process that holds on to the handle. So it will actually tell you, what applications are using it. I have to run this as an admin apparently, because it's looking in the handle table. So just to show you. So. For example, I use this all the time if Windows tells me, like, oh, you can't actually unplug this USB drive at this point safely because something is still using it. And then you simply use handle to actually see what's still using it. And quite typically, it's you're CD'd into it in a command line, so you have to CD out of it, something like that. So I can say handle dev.env.exe, for example. Oops, CD sysinternals. So here, well, no matching handles. Well, whatever, you can use handle here, and you will actually find stuff. Well, this is all the handles on the system. Oh, I have to do the full path. But anyway, so this actually allows you to debug this kind of stuff. But as I run this now, you will see after a couple of seconds that something terrible happens. And the terrible thing that's actually happening here is that obviously you can't update the UI thread from a non-UI context, a traditional kind of issue in UI updates. Whether you're using WPF or Windows Forms doesn't really matter, or even the modern UI stuff. So what async does is actually, when you write an async handler here, an async event handler, you can await the task, and then instead of doing all of this continue with voodoo, you basically just write the code that has to run after those 2 seconds over here, right? And somehow mysteriously this does work. Like if I press F5 over here, like there's no cross-thread violation exception anymore. So what's really going on here is that at the point the await starts listening for the event, or basically sets up the continuation, it captures the current synchronization context. So the synchronization context.current. And then, when the await completes, it posts back to that one to actually run the rest of your code in that particular context. So it actually travels back to the originating place. So that's very useful. However, if you're building libraries, when you're designing libraries that use async and await inside, it's kind of redundant for you to actually capture the synchronization context yourself, because the top-level application that's actually using your library will also do an await on your operations. So there, it already has an opportunity to capture the synchronization context. So you don't have to do that at every single point in time. So there is this thing called configure await that you can use inside libraries, where you say, I want to do configure await false, and that basically says like continue on captured context false, which means that the thing will not travel back to the original synchronization context. So it actually avoids that overhead. Now, synchronization contexts are often used to carry more information than UI affinity. So like in this particular case, this is a pretty clear exposition of this kind of problem. But like, for example, in ASP.NET, I believe they use the synchronization context to tie things back to the originating web request or something as well. There's also the execution context, which is a different context that is not disabled by configure await, because that has to do with security. So you can't actually override that default. But so configure await is like one of those little gems in the framework to actually look out for at some point. Any questions about the async and await features, actually? I don't know whether we have content about that this week, but it's going to be a pretty important language feature to use in modern UI applications and so forth. Yep. Can you repeat that a little bit louder, maybe? Mm-hmm. Okay. Oh yeah. So so say that you have an async method, and you want to run a task, but you don't want to wait for the result. So you have a couple of options, right? So either you say like, well, ultimately somebody has to wait for it at some point in time. So you can always use task.whenAll to actually return the task out of your method, to actually carry the task that you don't want to wait for yourself out of the method. A second thing is maybe you still want to wait for the task at some point in your method, but not immediately upon obtaining it, right? That's a pretty common pattern where you actually say, I want to do like, web client or download string async. I get a task back, but I don't want to do a wait immediately. I want to do some other processing first. And then at the end of, that processing, I want to await the task that I got back out of, download string task async. So you can actually interleave some work there so that you don't have to wait for the task immediately. So you can do that kind of style as well. Of course, you can do fire and forget, so you can just drop the task on the floor, which means it's just running for its side effects, like nobody's awaiting the outcome of that. If the task actually failed, you will get the unobserved exception handler to actually come in at that point and tell you that there was something going wrong. But what's the concrete scenario where you say like you have a task? Mm-hmm. I see. Yeah. So it's really about background loading in some sense, right? So yeah, you can use things like task.run, for example. You can simply use continue with for those kind of things, because you're saying like, I'm downloading pictures, but I'm never gonna wait for all the pictures to be downloaded. They just all go in separately, which doesn't mean they are running on their own threads. It just means there's a lot of I/O operations happening and nobody's awaiting all of those. So at that point in time, it's just a matter of like actually starting the task, right? Like, kicking off the task, not awaiting it. The compiler may actually say like, hey, you're getting a task that you're not awaiting. You can actually suppress that error or that warning in that particular case. There are legit scenarios where you actually don't await the task, yeah. Mm-hmm. Okay. Any other questions? Yes. Oh, I see. Okay, so the question is, say you have an ASP.NET request or something, and there you're awaiting some web service operation or something. Will it tie up a thread? The answer is no. So what's really going on is that you shouldn't identify tasks with multi-threading in any shape or form. It's just one case of using tasks that can result in having a different thread. So what's really going on in that case is like you're doing your web service request using async, right? So you're doing an async web service request. All that's really happening is that at some point, a completion thread pool thread will be queued to actually say the thing has completed, and now it will actually start doing the remainder of the processing. So there's no thread actually blocked during that entire time frame. Now, that being said, the requesting thread, how it correlates things back to the user, like that I do not know. If IIS says I'm doing an async stuff, and, every time an async request comes in, I need to have my own thread pool thread or something, and top level, they're doing some wait, at that point, it would actually keep a whole thread alive. But I know the async page handlers actually don't do any of that kind of stuff, so. Yes, yeah, totally. So yeah, at the lowest level, it all comes back to asynchronous completion of the network stack, right? So at that point, an I/O completion thread is actually queued. In the CLR, you can actually, if you look at the CLR, you actually have in the thread pool you have two pools of threads. You actually have a thread pool for asynchronous operations, and then you have one for user work. You can actually see that over here. You have, if you do get min threads and get max threads, you actually see that there's work threads and completion port threads. The completion port threads are the ones that are actually being queued, and they're not subject to the thread pool sizing that you typically have with tasks and queue user work item kind of stuff. So there is actually a separate set of threads that are actually purely there to handle the responses to asynchronous operations. And so that's at that level, it's actually purely tied to the completion port stuff in WinSock and all of those kind of libraries. But I would be surprised if a complete thread is destroyed in the process of doing like an async page handler or something, and I don't think it's the case. Yeah. Any more questions in the area of async?
Do you have any specific tips and tricks for developing async
Mm-hmm. Okay, yeah. So any particular pitfalls or recommendations on building asynchronous APIs? Let's see. First of all, when you're building libraries, I would always put the task unobserved exception behavior back on. By default, we actually disable that now. So there's actually a config flag, which I don't know off the top of my head, but it's something like throw unsupported. Oh no, throw task unobserved, something like that. So there's basically a flag that you have to that you can actually set in the app.config file. Here we go. Throw unobserved task exceptions. By default, that's disabled now. So it actually means that your application doesn't die in case you have like an unhandled exception somewhere in a task. So when you're developing libraries, you should actually put throw unobserved task exceptions back to true while you're developing, so you can actually catch those kind of issues. So that's one thing. The other thing in general is if you build your libraries using async await, and I've actually done a few of those lately, and you're dealing with tricky synchronization cases, doing the await in the same go as the execution of your code. What I mean with that is like doing await immediately on top of task.whenAny or task.whenAll. That kind of stuff is useful, but unfortunately, like, because it's an expression, you have everything in one go, so it's hard to debug. So I actually take those things apart, so that I actually have the task.whenAll sticking in some variable, so I can actually inspect in the debugger. So, for example, if you do task.whenAll to wait the completion of a lot of tasks, sometimes you have this mysterious effect of like, well, I have 5,000 tasks, and for some reason the thing doesn't move on. And then you want to inspect, the whole array and sort of see like, which of the tasks hasn't completed yet. So, so actually splitting those things out makes it easier in the debugger to actually start analyzing why certain tasks haven't completed yet. So that's one more thing. And in general, if you use the combinators, I think the combinators are very powerful, and they're almost never wrong. Like task.whenAny, task.whenAll. The thing is, in some cases, they do so much stuff for you that you may see a phantom effect, and that's if you do large-scale data processing scenarios like I was dealing with. The problem was that there was a lot of tasks being started, and things were sort of looking like they weren't really responding anymore. Like things were really sluggish. And what really was going on was that the thread pool started inflating. I had a lot of those long-running tasks sitting there, and the creation of new tasks was actually being slowed down intentionally by the thread pool, saying there's a lot of workload coming onto the system, I shouldn't start creating new threads. And so for that, you can actually use the performance counters very effectively to see, thread creation in the thread pool starting to slow down, exponential back-off kind of effect. Now, other than that, async programming in general is still pretty tricky. So, no silver bullets there. Yeah. Okay. I have a few more minutes, actually. I think it's counting down, yes. Any more questions? I can fit one more question. Okay. Let me just give you one more trick, actually. Let me think about one more trick here. One thing I've used very recently that's useful if you... Is there any one of you actually doing interop with native libraries at some point? Maybe it's too far. Okay, so likely you already know this kind of trick. But having managed executables, with the JIT, a managed executable always wants to have affinity to whatever the bitness is of the CPU, unless told otherwise. And Visual Studio has sort of gone back and forth in setting the defaults of what the bitness is, or the architecture is of your executables. And so this little tool called core flags is very useful for that. And in fact, like if you look at core flags, what you can do is like in the days of WPF, I had a lot of that kind of stuff going on. Like, somebody gave me an application, they were doing interop with some bitmap renderer kind of voodoo. And then the problem was like, well, the executable was being loaded in a 64-bit process, and then it wanted to, use some 32-bit, like, library or something. And you didn't have the source to recompile it. So, the simplest way to actually get around those kind of issues is by using core flags and actually saying, dear CLR, I want this executable to be forced to run on 32-bit. So you can actually do core flag / 32-bit required plus. And in fact, there's a new flag that was just added. And I'll leave it to the to folks over here to figure this one out. There's a new flag for 32-bit preferred, which actually has to do with ARM. ARM devices are actually using 32-bit processes as well. And that actually has to do with this particular thing. That's in addition to .NET 4.5. But those are actually very useful if you have an executable that's compiled as any CPU, and you still want to see how it behaves on pure 32-bit or pure 64-bit. You can actually use this little flag. So that's a little more tidbit over there. So, I hope this, there were some, for everyone there was at least some useful thing, like, whether it's RX or async or, I don't know, all the things we actually talked about, some debugger kind of tips and tricks. Please let us know, like, if this is a formula that you think is useful, whether there are some adjustments that can be made, like people submitting questions live using something like Twitter or something. We are open for a lot of suggestions there. I have one more talk today, which is actually about internals of C#. So if you want to see some more, maybe some SOS stuff at some point, or you want to sort of, see the IL code behind certain C# language features just to satisfy your curiosity why certain things work the way they do, I think that may be an interesting talk for you as well. With that, I hope to see you again at some point, and thanks for attending. Thank you.